I hope you enjoyed the Zermelo-Fraenkel axioms. But remember, mathematicians then discovered that not everything can be proven using these axioms. So that's where the continuum hypothesis, remember the continuum hypothesis said, asked the question, or basically posed this question, that there is a set that has a cardinality larger than the natural numbers and less than the real numbers. So the continuum hypothesis, that cannot be proven to be true. So what we have is we have this statement that it can't be proven to be true, but on the other hand, is it false because we can't prove it to be true? Well, no. If what they showed later on was that if you try to work with this negation, you also can't disprove that. So we have the statements, we have mathematical statements that make perfect sense, right? You understand what I'm saying when I state it. It's a very sensical statement, but yet we can't prove it to be true, nor can we prove it to be false. It is independent of the axioms. So in 1931, Gödel was a famous mathematician. He did a whole lot in the world of logic. He discovered his incompleteness theorems. There's these two famous incompleteness theorems. So basically what they state, or at least one of them that they state, is that for any system of axioms where natural numbers are used, and we're doing adding and multiplying with those, that's why I said geometry doesn't really fit per se, but mathematics that we're used to doing adding and multiplying with, there will always be statements that are true but unprovable. So every single time, no matter what we did, if we wanted to say, okay, those Zermelo-Fraenkel axioms stink, I want to create a new axiom system that still uses it adding and multiplying, I still am going to have statements that make sense. I simply cannot prove them, but they're still true. So what that means is that there's statements out there that are true, but we can't prove them to be true, and that's okay. We just have to deal with it. That is the weakness that mathematics has. We do not have the ability to prove every single thing that is true. We can't prove that it's true. We just have to accept some things by faith. So we have some questions about what does it even mean to be true? How could you say that that's true, but I can't prove it, right? Because you're like, well, yeah, we prove things that are true, and we disprove things that are false, or I find counterexamples for things that are false. How can you have something that is true then? What does that even mean? Where does truth come from? So we have these questions that are trying to figure out, what does it even mean? How do we even believe that 1 + 1 = 2 anymore? What is that? How is that true? Well, we have a whole lot of discussions. There's questions about, is there such a thing as absolute truth, or is there no such thing as absolute truth? So it makes sense, especially mathematically, that we believe, no, there is an absolute truth, right? It's not one day that I'm like, oh, I'm going to add 1 + 1, and this time I'm going to get 5 instead of 2, because I'm feeling like that's 1 + 1 = 5 instead of 2, right? So we have these things that we just believe to be true. We just have these underlying assumptions of truth. But the question of where does truth come from, that leads to a lot of philosophical discussions that you could delve really deep into a lot of the philosophy of math, and it is very, very interesting. It is some weird things, but it's really good to understand how does truth work from a mathematical understanding, because we all, I think, are trying to understand what is the truth that's out there. We don't want to live in a world where we believe things that are false. We're trying to believe things that are true and understand those things. So if we believe that truth comes from God, because a lot of Christianity basically says, listen, God is the truth, right? So Jesus even said, I am the way, the truth, and the life. So if we believe that God is where truth comes from, if that is the ultimate absolute source of truth, then what that means is that when we're studying things that are true, which we are doing mathematically, right? This whole class, we've been studying things that are true, right? We've proven that the sum of two even numbers is even. That's something that's true, right? Then, if when we're studying those things, then by studying math and the truths that come from math, then we're studying aspects of God himself, right? So by studying mathematics and understanding what is truth, we get to actually understand who God is in a better way than a lot of other disciplines, right? A lot of other disciplines aren't saying, I study truth. Like in literature, there's no concept of truth. Even in science, there's a whole lot more there that you're like, well, I mean, there's a lot there that I don't really know is true, right? You have experiments. You don't have axioms. Really, the foundation of science is mathematics. anything you're doing is all going to be based off mathematics. Even philosophy, the foundations of philosophy is logic, which is mathematics. So by studying anything that is true, we're really studying aspects of God. So that's something that as I study mathematics, I realize, wow, I'm actually doing something that helps me understand a greater understanding of who God is. And I've had many conversations with people, which you should be prepared to also have the same, who have really deep questions about the universe. And by understanding mathematics, I can actually understand those things better. So, an example, I think it was maybe 2 years ago, I had this kid that I went to high school with. Out of the blue, he was like, hey, listen, I've been thinking about this idea of God, but how is it possible that God can exist everywhere, but yet he doesn't take up everything? So how can you have this God that's seemingly everywhere, that Christians claim God is this omnipresent being, but yet we don't? It's not like God's just like in my face right now and like I can't move around because God's in the way. How does that work? Well, I could relate that mathematically to saying, well, let's talk about the sizes of infinity. Let's talk about the set of rational numbers and the set of real numbers. Remember, we said that if we looked at the set of rational numbers, we said that between any two rational numbers, you have an irrational number. But then between any two irrational numbers, you have a rational number. So that means between any two numbers, you have a rational number. But there's an infinite number of these, but yet you still have a much larger size of infinity with the irrational numbers. So if you're an irrational number, even though you're somewhat surrounded by rational numbers, you still have this, you're still so much larger, there's still so much more space that the rational numbers are not taking up. So that helped me understand a little bit more of trying to explain to him, like, no, like mathematically we know and we believe that this is true, and people don't doubt this fact. It is, I mean, if you were to say to a mathematician that that's false, you're an idiot, right? Mathematicians are going to be like, no, that's absolutely true, these facts about rationals and irrationals. But then we try to understand it to other situations. It helps us have a broader understanding of the universe around us by looking at some of these weird concepts of math that seem to be counterintuitive. They seem to be false, but yet on the other hand, they're still true.